Good morning, everybody. I hope you're doing well. Welcome to Wednesday or whenever you are seeing this video. Today we're going to continue with the law of signs, but we're going to talk about something called the ambiguous case today. Now, as a quick review, the law of signs can be used anytime you are given one side and any other two measures, sides, angles, whatever you want. This special case happens when you are given two sides and a non-included angle. And yes, I am not going to write that in the other direction. All right, so the first case I wrote is fairly straightforward. It's when you're given an angle that is obtuse. And the obtuse angle, let's draw it right here. Okay, there's the obtuse angle. I'm going to call it angle A. And I'll even draw a little arrow. I'll write obtuse, you being obtuse. There we go, and this will be side B because recall, angles and sides with the same letters have to be directly opposite each other. So it says if A is a side that's greater than B. So let me draw a side A that's longer than B because it says A is greater than B here. Look what I get. I get a triangle, and I get specifically one triangle. Okay, what if A is less than B? Let me draw the same exact picture. And there's angle A there. It's obtuse still. Here's side B. And now let me draw side A, but it's not as long as B. I just have a line, in, space. It's just sitting there. This thing's just going to be like, it's just going to dangle. And I will get zero triangles, no triangles there. There we go. So when the given angle, the non-included angle is obtuse, fairly straightforward. You either get one triangle or you get no triangles at all. All right. Things get interesting, I wrote, when the angle is acute. So let's talk about this here. First off, let me draw an acute angle. Here's angle A. And now it's acute. And I could do the whole corny math jokes. I'm not going to do that. All right, so this is still side B right here. And it says if A is greater than B, let me draw a line that's greater than B. There we go. If that's side A right there, directly opposite angle A, I'm only going to get one triangle. One triangle and one triangle only. What if A equals B? Well, I kind of wrote it already. I'm just going to write it. You get one isosceles triangle. So here's angle A right there. It's acute. Here's side B. Here's side A. And they are congruent. And then you get an isosceles triangle. And I'll use a red pen for this because that angle is the same right there. Keep this in mind because we're going to be using isosceles triangles a little bit later in this lesson. It's going to pop up. Okay? So that is if A is greater than B or A equals B. Things get really interesting when A is less than B. So if A is less than B, all right, so let me draw an acute angle. I'm just going to do it for each. Acute angle, acute angle, acute angle. There we go. I tried to be as similar as possible. The third one was a little larger. So angle A, and angle A. All right. If A is less than B, but then I wrote if A is equal to H. What is H? H is the height of the triangle. All right, so let me talk about this right here. If A equals H, let me try to get a different color here. Let me use a highlighter. That is H right there. H is the height, but when I draw the height, what type of triangle do I create? I create a right triangle. But all right, so now let me draw a black line right underneath that highlighter pen. If side A equals that H right there, this is H. How many triangles do I get? I get one triangle. And not only do I get one triangle, but that triangle is a right triangle. Okay, so for all these, I am going to draw H. There's H right there, and there's H right there. And keep in mind, that creates right triangles. What if side A is less than H? All right, so you know what? Let me do H in red. H is in red, H is in red right there, and H is in red right there. If side A is somehow less than H, it's going to be that, it's just going to dangle back and forth. How many triangles will I get if A is not even as long as the height? I'm going to get 0 triangles. So while I said it gets interesting, it's not necessarily that mind-blowingly difficult. You just have to think of the situation. Last but not least, what if A is greater than H? So here's side B. I forgot here's side B as well. What if A is greater than H? All right, here's side A right there. And I'm going to say that that's greater than H. There it is. It's less than B. You could see it's more steep than B. The slope is, more steeply negative. But it's bigger than H. So I definitely have one triangle right there. There's one. But watch this. What if I take this swing arm right here and I swing it around? Now watch this. Magic of the screen. Boop. Where'd it go? And then what if I draw another triangle right here? It's the same A. I just swung it around because it's longer than H. I should swing it down like this. Sorry. That's a better swing right there. I swing it like a pendulum. How many triangles do I get if I take that A and swing it like a pendulum on either side of H? I get 2 triangles. I get 2 triangles. Let me go back and draw this one more time right here. Okay, but I want to point something out before I even go to the next page. You know what? I'm going to do it in my moon pen. All right. Look specifically at this triangle right here. When I swing A like a pendulum, I want you to pay attention to the fact that this angle right here will be the same as this angle right here. It's an isosceles type triangle right there. That piece of it. Oh, let me erase that. Let me erase this. This triangle right here is going to be isosceles. And so the angles are the same. That's important when we do calculations in about 5-10 minutes or so. Okay, so those are all of the ambiguous cases right there. Let's get to some examples and let's make the magic happen, okay? Let's do it. For triangle ABC, determine the number of triangles, then solve the triangle. So the first thing I'm going to do is I'm going to determine whether it's case 1 or case 2. Case 1 is an obtuse angle. Case 2 is when the angle is acute. So let's get to it. So first off, this angle right here is an acute angle. Immediately, this is case 2. All right, immediately it's case 2. And so I am going to do my best and draw myself a 32-degree angle. That's somewhat close right there. There's a 32-degree angle, and that's angle A. Side B is 42. And side A, which I'm not going to draw yet, is 30. The first thing I need to find, because, and I'm going to make a note here. A is less than B. A is less than B. We need to find H. When A is less than B, let's go up here. We have to find H. It's this case right there. A is less than B. So let's find H right now. That's why I got the highlighter pen out real quick. Let's find H. How do you find H? Well, don't overthink this. To find H, it's simple trig. H is right here, and I'll do it in red as I have been doing. Okay. Isn't H the opposite side of 32 degrees? It is. And isn't B the hypotenuse? So which trig function uses the opposite side over the hypotenuse? I'm not even going to keep going. It's sine. So I'm going to say the sine of 32 degrees equals H over 42. And if I calculate that out, I multiply by 42 on both sides, so H equals 42 times the sine of 32 degrees. I get H equals a number, and that number is 22. So now we know that H is 22. Let me write that on the inside right there, 22. Okay, so now let's compare A to H. Remember, let's go up here to our notes. A could be equal to H, A could be less than H, or A could be greater than H. And that determines how many triangles we get. So what's the case here? H is 22, A is 30. A is greater than H. So how many triangles do we get? We get 2 triangles. There it is right there, 2 triangles. So we're going to get 2, count them, 2 triangles. It's going to be that case. You knew I was going to give you this example, everybody. You knew it. So let's get to it right now. First and foremost, let's use the law of sines and find out one thing that we know. All right, so I know that A equals 30. So let me just draw that right here. I know that A equals 30. All right, so the first triangle, triangle number 1. I'll even write that right here, first triangle. Let's set up the law of sines. Remember, it's the side divided by the sine of the angle. That's not going to change. So then what do I need to find here? I need to find angle B, and I need to find angle C. Okay, so let's get to it right here. All right, so 30 over the sine of 32 equals, let's find angle B. So 42 over the sine of angle B. So if I cross multiply, I'm going to get 30 times the sine of B equals 42 times the sine of 32. And then I could divide by 30. Great. Magic of the screen. I'm just going to make 30 disappear there. Great. Now I'm here. So how do I find out B? I take the inverse sine on both sides. So B is going to be the arc sine or the inverse sine. So B, angle B is the arc sine of this whole hugabaloo right here. Whew. All right. So angle B, let me write it up here. Angle B, once I plug that in, equals 48 degrees. And I'm just gonna cut to the chase right now. Okay, I'm gonna cut right to the chase. If I add up 48 and 32, and then I subtract from 180, hopefully you're hearing that right there, C is gonna equal 100 degrees. So there's that right there. Oh, what else do we need to find? We need to find side C. Fine, let's find side C right now. Okay, side C. Now that I know that angle C is 100 degrees, I'll even write that in there. 100 degrees, and this is 48 degrees. I could find C very quickly. All right, and let's just find it right here. I'm going to use the same setup. 30 over the sine of 32 degrees equals side C over the sine of 100. Okay, and now I'm going to find side C. Side C is just going to be what here? 30 times the sine of 100 all divided by the sine of 32. And what will that equal? Let me draw it right up here. Side C is going to equal 56. So let me draw one big line right here for the first triangle. All that work relates to the first triangle. Pause, rewind this video anytime you have any questions about what we're doing. Now, we found the first triangle, but now we need to find the second triangle. Oh my goodness. All right, so how do we find the second triangle? And I'm going to write that work somewhere else on this sheet. Do I have room? Yeah, I'm going to put it right here. Second triangle. All right, let's get to the second triangle right now. So what I'm going to do is I'm going to take my moon pen and I'm going to swing side A around. And by the way, while you're doing your homework, you can make that sound effect. Your parents will think you're really cool as you're in the other room doing your math homework. Oh my gosh, they won't think that you are having quarantine issues. So let's move right along. Now, this is, some of you might go, all right, well, we're trying to now solve this triangle. So let me even draw that on my picture right here, right there, and right there. This is still 32 degrees. This is still 42, and this is still 30. But here's what we do know. If, I'm going to draw a little dotted line right here. If this angle right here is 48 degrees, when I swing it around, I get an isosceles 48 degrees right here. So this is also 48 degrees. Let me make life really easy for you. This angle right here is just going to be 180 minus 48. So what is 180 minus 48? That's 132 degrees. So angle B, without doing much of any work at all, because the triangle that I create when I swing around side A is an isosceles triangle. How cool is that? It took me a while to, fully grasp that concept myself, but once you get it, you get it. So 132 degrees. If I take 132 and I take 32 and I add it up and I subtract from 180, angle C is 16 degrees. Bada bing! Wow, how much less work is that? The only thing left to find is side C. So remember, this is 16 right here. So now I'm just going to set up the law of sines again. The first setup is easy. 30 divided by the sine of 32 degrees equals side C over now the sine of 16 degrees, because angle C is now 16. So side C is going to equal 30 times the sine of 16 degrees divided by the sine of 32 degrees. And if I plug all that in, I get C equals 16. Well, that's coincidental, right? Yes, that is coincidental. Angle C is 16 degrees and side C is 16. That doesn't always happen. All right, but I just wanted to make sure that you understand that's what's up. All right, so we did all that work and we got our answers right there. I gave this example as example 1 because it doesn't get more complex than that. Two triangles, working on through, understanding that when you swing around side A, you get an isosceles triangle, and then just subtract from 180 makes it that much not as bad, if that's even a word. Okay, so now let's get to the rest of this. I have 5 examples and we're done for the day. Okay, so given the following info, determine the number of triangles. So this is obtuse angle. Let's just go through this. This is how you can handle your homework. It's obtuse, so that's case number 1. And if it's case number 1 and A is less than B, let's go. And just consult your notes. If it's case 1 and A is less than B, there will be no triangles. So 0 triangles. All right. Once again, we are obtuse. Every time I hear the word obtuse, I think the Shawshank Redemption, if you've ever seen that movie. Case number 1. Again, this time, A is greater than B, and if it's an obtuse angle and A is greater than B, there it is right there. A is greater than B. There'll be one triangle. So you got one triangle. Part of your homework is just doing this. This is so not bad. Uh-oh. This is an acute angle. It's an acute angle. So it's case 2. All right, but I noticed that A is greater than B. So let's go up to our notes. If A is greater than B, there it is right there. Case 2, it's an acute angle, but A is greater than B. Just one triangle. Straightforward. One triangle. All right. Once again, I'm just going to cut to the chase. These are both acute angles, so case 2. And this is acute angle, so once again, this is case 2. Here, I decided to mix it up a little bit. Instead of just giving you a triangle ABC, now angle C is the one in question. It's always the side that's across from the given angle. That has to be greater than or less than something. So here, C is less than B. Uh-oh, we have to find H. So if it helps, draw yourself a triangle. If drawing a triangle helps you visually do it. This is 77.3, and side B is 14 right here. And then you could draw H. I always like to do H with a highlighter pen. There it is. So there's H. Oh, I promised I'd do it in red. Okay, so let's do the trig. The sine of 77.3 degrees equals opposite side, which is H, over 14. And so multiply by 14, and H equals 14. Should have done that in red, sorry. So how can I compare C to H? Let's do it right here. C is 10, H is 14. C is less than H. Let's consult our notes. If the angle in question, I know it's A here, but if C is less than H, how many triangles do we get? We get the dangler. We get 0 triangles. We get 0 triangles. That's the answer to this one right here. And last but not least, we have to find H. Draw yourself a triangle if it helps. Just letting you know, I always draw myself a triangle. So we have 55.6 degrees. And then we have C is 15 right here. This is angle B this time. Oh, I'm just mixing it up on y'all. And then we have the hypotenuse right there. And H. So let's set up the trig. Sine of 55.6 degrees equals H over 15. So H is going to equal 12 in this case. I know I'm skipping over a lot of the math. You just multiply by 15 on both sides. All right, let's compare B to H this time. Ooh, B is 13, H is 12. B is greater than H. So let's consult our notes for the very last time. If the angle in question is greater than H, how many triangles do we get? We get 2 triangles. We get 2 triangles. There we go. All right. I hope you found this helpful. We went 24 minutes and 15 seconds. Bye, everybody. Email me or message me if you have questions.